So this is a new type of relationship called function composition. Function composition. And when you see this, so I'm gonna show you, okay, we'll just go for it. So we have q of x is equal to x squared plus 5. And then in green, I'm going to use r of x equal to the square root of x plus 7. So you've seen where we've been able to like add these two functions together, and we've been able to multiply these two functions together. But now I want to do something where I'm doing what's called function composition. And the key to function composition is that you're just basically doing substitution. So it's just like a really fancy way to do substitution. And then we talk about it in really specific ways. So when I have, and this just wants r of q of 2 and q of r of 2, I'm going to find q of r of x and r of q of x first. So first off, it wants r of q. So we want r of q of x. And notice how I'm saying that. R of q of x. Okay, and think about what just like this part means, q of x, right? That's telling you q is the name of your function, and then of x, well, x is what's going in where the variable belongs, right? So here, when I take this this longer one where I have r of, what am I putting in for r, right? So I'm going to the function r, and instead of x for my variable like I have right here, we're going to take all of q of x, and we're going to plug it in. So let's see what that happens. So when I expand this out, so this is what it looks like, r of q. This is what it looks like when we have it like foiled up. So if I take this expands out to, and this is where I'm going to color code it, r of, and inside of that, q of x. So again, both this and this is read as r of q of x, r of q of x. There's no multiplication going on. No multiplication. This is how we utilize the symbols are changing now. I know that you're used to the parentheses meaning multiplication, but that's not what that means here, right? So we have to be really careful. Okay, so we're just going to substitute. So remember, when you're doing PEMDAS, right? When you're doing PEMDAS, it says go to parentheses first, the innermost parentheses. So we're going to the innermost parentheses. So x, well, there's nothing to simplify with x, so x is x. Okay, so q of x. So I'm literally going to take q of x, and I'm going to replace it with its equation, x squared plus 5. And that's it. All I've done, that's just substitution, yeah? From here to here, and that's it. Okay, and now I just want to reiterate again, r of x is what I have written there, but what if I had r of a, right? Isn't it just everywhere you have an x, you now replace it with that a, right? So this is the square root of a plus 7. Well, look, now a is that whole bit, x squared plus 5. So now I'm going to take that and I'm going to plug it into, I'm going to take this, and this is replacing my variable here in the equation r of x. And I know it's in the equation of r of x because I have r of x squared plus 5. So r of x would normally be the square root of x plus 7. That's r of x. But I want r of x squared plus 5. So instead of this x right here, we would have x squared plus 5. Right? And again, we're substituting. right? Each of these steps is substitution. My first substitution is taking the name of my function and substituting it for the equation of my function. The second, that's this one. The second substitution is taking the variable of my function, r of x, and replacing it with this guy. So I'm taking this variable and I'm replacing it with that. And then now we're done, right? There's no more, oh, sorry for the yellow. That's really hard to see. There's nothing left to do but simplify. And so now it's just simplifying. All right, well, if I simplify, I can drop those parentheses. So x squared plus 5 plus 7, or the square root of x squared plus, 12. And so this is r of q of x. So we have a new function. It's not r, it's not q, it's r of q of x. Okay, so that's substituting it one way. What about the other way around? Well, let's go ahead. Let's take these with us. And we did r of q, so now let's look at what is q of r of x, right? And so again, right, I'm gonna just play this, so I'm gonna expand this out. So q is on the outside now, and r is on the inside, because the way I rewrite this is r is the furthest to the right, so it's the innermost function. Okay, and so now what I'm gonna do is, again, I'm just gonna substitute, right? I am going to substitute r of x for its whole equation, yeah? And so what's its whole equation? Well, its whole equation is the square root of x plus 7, right? And now that is going to be my new variable up here, right? Now I'm replacing the variable in q of x, right? I'm replacing the thing, that x that's being squared. So we're going to take this x and we're going to replace it with all of this. So here we go. So normally, if it was q of x, it would be x squared plus 5. I'm doing that, sorry, it would be x squared plus 5. That's q of x, right? But I want q of this guy. So instead, I'm not going to have that x. And instead, what am I putting in there? I'm putting in that square root of x plus 7, right? Again, it's substitution. All of r of x is going in where the variable is in q of x. And so again, what were my steps? From here to here, it was substitution. And from here to here, what did I do? Substitution. Right, my first substitution is substituting the name of my function for its equation, name of the function for its equation. My second substitution is taking the variable of my original equation and replacing it with the new thing that I have, right? And now, what do I have left? All that's left to do is simplify. Okay, so if we simplify, let's go ahead and simplify. Well, that square root and that square cancel each other out, right? So this is just x plus 7 plus 5, or x plus 12. So this is q of r of x. So if we look at q of r of x, we just get back the linear function x plus 12, but if we took r of q of x, we got back the square root function where it's square root of x squared plus 12. So what I'm saying is that the order that we plugged in mattered. Okay, so this is the more difficult version of what you're looking at. I want to talk about this so that way you can see what we're talking about. Now let's go to what the actual question is. Go ahead and borrow this. All right, we just want to find, in the actual question, we're just trying to find r of q of 2 and q of r of 2. So again, I'm going to color code these. So was I using, yeah. So q of x is x squared plus 5, and r of x is the square root of x plus 7. All right. Now if I'm trying to find r of q of 2, well, I could go back up to this equation because it's r of q of x, and I could just plug in 2, right? R comes second, r, right? Q's the innermost, Q's the innermost. I could take this one and I could plug 2 into this and figure it out because we went the long way. If I didn't do that for the questions that you're doing, right, I could say, hey, this is equal to r of whatever q of 2 is. So I can go, hey, aside, what is q of 2? Well, that is 2 squared plus 5, okay? Which is 4 plus 5, which is 9. So now I am allowed to substitute q of 2 for the number 9. So q of 2 is equal to 9. And so again, it's substitution the same way that when I substituted this guy for that guy, it's just substitution, right? That's it. We're just substituting. Okay, so now I'm going to do r. So now this is really the question, r of 9. So what's r of 9? Well, this is equal to the square root of 9 plus 7, right? Because I'm taking this guy, r of x, and I'm plugging 9 in. So again, simple substitution, right? I'm replacing r for what it's equal to, yeah? And now it's solving, so let's solve. So this is the square root of, 16? And the square root of 16 is 4. And so my answer, r of q, r of q of 2 is equal to 4. All right, if we do it the other way around, we found r of q, now we want q of r. So I really want you to pay attention. It really matters what order we're doing stuff in, right? So now we're doing q of r of 2. Right, this is the, sorry, I jumped. Q of r of 2. That's what we're trying to solve. So this is really q of whatever r of 2 is. So again, I can say, hey, you know what? Aside, what is r of 2? Well, r of 2 is take that x and replace it with a 2, right? So I'm going to have the square root of 2 plus 7. Yeah? Okay, and then that will equal the square root of 7, 8, 9, the square root of 9, which is 3. So I know that r of 2 is in fact 3, so I'm going to take r of 2 and I'm going to replace it with 3. And again, It is substitution. So when I say substitution, I mean substitution. So we're going from this way that we talk about y, because right, this is normally y equals, but this, right, we talked about this, that the function notation lets us do cool, weird things, and this is one of the cool, weird things that it lets us do, is it lets us take an x value, run it through one function, and then run it through another, and then run that answer through another function. So we're taking our x value 2, we're running it through r, whatever that pops out, now we're running that through q. In this case, it pops out a 3, so now we're going to run 3 through q. So what would we get here? Well, we're going to take q of x and instead make it q of 3. So this would normally be x squared plus 5 if we didn't have a value, but we do. So it's going to be 3 squared plus 5, right? All I'm doing is I'm substituting, yeah? That 3 gets replaced, that q of, and now again, it's simplifying. So this is going to be 9 plus 5, or 14. So we're going to get back that q of r of 2 is 14. So look at how different they are. In one, when q is the inner function, my answer is 4. When r is the inner function, my answer is 14. So very different, right? And that's it. So it is just substitution. Do not overthink this. Notice that once I do my substitution, the name of the function goes away, right? Because I ran it through. The name of the function goes away because I'm switching over from the name of the function side to the equation side, or to the answer, depending on which part. Same thing up here when we were doing the more complicated version, when I switched from, right, the left-hand side, the name of Rx, to the right-hand side, the equation, there's no more R right here, right? This is R of X, yeah? And same thing down here. I'm not writing Q anymore because I switched from the name of the function, right? The name of the function to the actual equation of the function. So here's the name of it, and here's the actual equation of it. Hope this helps. Let me know. I can find some more videos. The other thing that you can do is, again, just look up this word, function composition. This is what they are trying to teach you, so you can go ahead and look that one up. All right, I hope this helps.